Okay. Um, Welcome back, everyone. Um, I just got a message as I was about to start. Um, there we go. Right. So we're back again with the advent of code streaming. Today, of course, is day number 7, as we can see here. So yesterday we were calculating lanternfish schools, I guess, since they are fish, like growth rate. We had to implement a different solution for day 2, simply because the number was so big that the naive solution for part 1 actually ended up crashing my computer, or not crashing the computer, but running it out of RAM and crashing the program. So someone had a good hint for me, and we managed to create a good solution. Day 7, haven't started looking at this, but let's get into it. Day 7, the treachery of whales. A giant whale. Is this? Okay, it's the Wikipedia article for sperm whales. Has decided your submarine is its next meal. That doesn't make any sense. Whales eat krill. We have to be bigger than krill. Well, I guess not all whales eat krill. And it's much faster than you are. There's nowhere to run. Or swim, I guess. Suddenly a swarm of crabs, each in its own tiny submarine. It's too deep for them otherwise. Okay, sure. Zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system, just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. Right, so we need to help the crabs blow a hole in the cave wall, I guess. Wouldn't that just flood the cave? Well, I guess if they blow a hole in the bottom, then it might be fine. Yeah. Right, there's one major catch. Crab submarines can only move horizontally. Guess that makes sense with crabs, in a way. You quickly make a list of the horizontal position of each crab. Your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions: 16, 1, 2, 0, 4, 2, 7, 1, 2, 14. This means that there's a crab with horizontal position 16, a crab with horizontal position 1, and so on. Okay. Each change of one step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. Right, so we have to align them vertically, so all of them need to have the same horizontal position. Right, that makes sense. I was like, so we need to sort them, or yeah. But no, this makes more sense. So from 16 to 2 is 14 fuel, 1 to 2 is 1 fuel, 2 is already 2, so it takes 0 fuel, so on and so forth. This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning at position 1, which is 41 fuel, position 3, which is 39 fuel, or position 10, which is 71 fuel. Right. Determine the horizontal position that the crabs can align to use the least fuel possible. How much fuel must they spend to align to that position? So we have our input here. Actually quite a big input. So we need to calculate basically the distance to any number, figure out the fuel distance, and then do that for all of our crabs in every position. I guess we could do that with just 2 simple loops. Let's have a look at this. So the numbers seems to go up to about there's a 1,500 here. So I guess we'll just do we'll try the trivial solution first. Let me actually name that part 1. So we're going to be using stereoutils again. We are going to have a min position, which is set to int.high, and a max position that we set to 0. So int.high is just the highest number an integer can hold. And then we do let crabs be equal to, let's read the file, which is our input. Let's actually do the input example thing that we've been doing in the past. Split that up on commas. And again, this input file doesn't, there's no space after the comma. And then you run mapit, and we say let number equals to its.strip.parsint, and then min-pos is equal to min of num and min-pos, and do the same for max, but obviously with max. So what this does, the minimum position starts at a super high number, and then it always chooses the smallest number of the number we have and the number that we're that is the current smallest one, and same for this one. So this should give us sort of our bounds, and then we just return num. So that goes into the mapit, and the sequence all of this returns is a number of integers. So if we now echo out crabs, and we can echo out min-pos and echo out max-pos, we should have, that is from secutils, of course. It was complaining that the mapit function wasn't defined. If we now run this, input example doesn't exist because I haven't created a file containing this stuff. Let's go here. And I want to, let's see, paste my clipboard. Pasting clipboards is something which is a bit weird in Nim. No, in Vim, not in Nim. Nim doesn't do clipboards in any useful sense. I mean, you have clipboard libraries, but it doesn't natively do clipboards. Right. So now we have our input, and we can do this. And that seems to have worked fine. 16 and 0 as our minimum and maximum. So now we can do for I in min pos all the way up to max pos, and then for crab in crabs. And we can say that the least fuel is again the highest possible integer, and we can say that fuel is 0, and then this will be the absolute, so fuel, we want to add the amount of fuel it takes to move this crab to the position that we're currently at, which would be the absolute value of position minus the crab. So absolute is just gonna take, so if this is a minus, it's gonna turn it into a positive. So if the crab is at a higher position than the position, it's just gonna calculate the distance. Right, and then we can echo out, and then least fuel is the smallest of least fuel and the current fuel for every position. And now we can echo out the least amount of fuel that it would take us. So this should work for our input. It says 37, and 37 is in fact our solution. Could of course for fun also do, could echo out all the fuels. Let's just not echo out this stuff. We can echo out all the fuels. So here we can see that we have 49, 41, 37, 39, 41, and then it sort of increases from here. So this actually looks like it dips down to our minima, and then it goes back up again. So it is possible, although we could have a dip down here as well, I guess. Maybe. It might be possible that we could have like stopped right there. But maybe not. Who knows? I guess it's pretty easy to find out. One thing we could have done is actually do something like this. Repeat is from the stereo-utils module, and it will just repeat this string n times. So if the terminal, my terminal is wide enough, so here we can see sort of a crude graph of the fuel consumption of getting to the different positions, and this is the most efficient one. So now we can run this on our actual input, and let's see what we get. I'm guessing that this is just gonna work. Oh, maybe I should have not done that. Actually, what we could do, not just echo out the fuel. I want to see what sort of order of magnitude this is at. Okay, so that was easy. Yeah, so if we take this, I just want to do something fun here. Terminal, I think that's what the package is called. I want to repeat dot. We want to do this divided by get. Isn't it called terminal? What I'm trying to do here is find the in this terminal. I'm trying to find the side, like the width of my terminal. Where is that? Let's see. It's just called terminal height, terminal width, not in get, terminal width. Terminal width, and times that by fuel. Oop. Of course, it should be the other way around. So take terminal width, divide that, and this is, of course, call that procedure instead of trying to divide the procedure. And this should give us, nope. Of course, we need to do this and then convert this to an integer, because this number is going to be super small. And turn float, oops, turn float in fuel into a float, so that the math works. So here we can see now the biggest one, or I assume this is the biggest one, takes up the full width of the terminal, and we can see sort of the same graph that we had before, and it closes into what I'm guessing is, oops, I'm gonna just click. I pasted something in, so my terminal went to the position. Okay, yeah, so here, these are the lowest positions, I'm guessing, and then we're heading back up, and that was actually quite, it was quite quickly in the set. And the further we go along, the more fuel we need. But enough of that. This should be our required fuel, which is the answer to the puzzle. Hooray! So now we are one gold star closer to finding the sleigh keys. So I'm guessing part 2 is gonna add some computational complexity. That means we can't do it in this sort of silly, obvious way. The crabs don't seem interested in your proposed solution. Okay. Perhaps you misunderstand crab engineering. That is quite possibly the case. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. Right. So a 4, yeah, a 4 is still 1 fuel. But a 5, 6, 7, that is 3 fuel. Wait. Oh no, we're moving to 5, of course. So 7, 5, 6, 7, that's now 3 fuel. The cost is a total of 168 fuel. This is now the cheapest possible outcome. The old alignment position 2 now costs 206 fuel instead. The least fuel possible so they can make an escape route. How much fuel must they spend to align to that position? Right. So this, let's see, first step costs 1, second step costs 2, the third step costs 3, and of course we need to sum them all together. That would be the same as what is that actually called? The exclamation mark. I can't think of what the name for that. So if I open a calculator here, we can do 3. So if you need to move 3 positions, and then this factorial, of course, is 6. So moving, let's see. Yeah, so moving 3 positions would be 3 plus 2 plus 1, that is 6. So factorial is just the same as saying 1 plus 2 plus 3 for the number 3. So we now have to do factorials. Of course, we have in our math module, we have fac, which calculates the factorial of a non-negative integer. So in our case, let's go back to the, before we do this, we want to store this in the part2 file, and we want to open the part2.nym. There we go. So now we're working on a different file, just with the same content. Input example, and we want to add the factorial of this. And factorial, factorial is of course in the math module. There we go. So running part2. Nope. We now get this as our fuel consumption for our example. That looks like a lot. Yeah, it should be 168, and we got a couple thousand. 93,625. We have done something wrong. So this should be the number of positions that we need to move. And that should be the factorial. This is something like, let's see. Where did that go? Here. Ah, right, so factorial of 0 is apparently 1. Deceived by my expectations. Oh, wait. Let's set the terminal size here. Import math. And then we want to do factorial of 3 is 6, yes. Of 4, that should then add a 4, so that should be 10. But it's actually 24. Oh, wait. Factorial is times. That's not what we want. Oops. Quit 0. Right. Yeah, so factorial is the numbers times themselves, not plus, like I said. Yeah, that's not what we want. Right. So we have to find a sum. Let's see. This brings up some memories from math class. Minimax. So I'm just reading comments from the NIM AoC IRC channel. Zoom says, yeah, I also got min and max on parsing, and now I can't understand why the hell I did it. Right. I expected the result to lay between the initial positions. Wait. You expected the result to lay between the initial positions. Wouldn't it always? Yeah, it has to always be. Otherwise, it would just be the end. And if you go one step further, and all of them would just be one bigger. So it's always going to be within the spectrum. Yeah, I forgot that factorial is times and not plus. Of course, can't remember the actual thing, but let's see. So if we do 1 plus 2 plus 3 plus 4 plus 5, so this is for going 5 positions. So 5 5 plus 1 is, of course, 6. 4 plus 2 is 6. And then we have the 3, which is 3. If we do 6, then we have 6 plus 1. 6 plus 1 is 7. 5 plus 2 is 7. 7. And 4 plus 3 is also 7. So if you do the the outermost ones all the way, they're always the same. Oh, right. Right. Yeah, so you thought the result would always be one of the numbers. Right. Yeah, no, that's possibly not the case. Right, so this means that this is 7, 14, 21, which is this plus 1 times itself divided by 1. So that would be x plus 1 divided by, x plus 1 times x divided by 2, which is x plus 1 times 2 divided by x. I mean, it's the same. Doesn't really do anything. But does that work for 5? So 5 plus 1 is 6. Oops. Times 5 divided by 2 is 2.5. Again, SL is short for stack-lang. It's a small calculator that I wrote. So 6 divided by 2.5 is 2.3999, which is obviously not the right answer, because that would be 1, 2, 3, 4, 5. 1 plus until. This is because of the calculator I'm using. So it applies the plus function until the length of the stack is 1. So until I have only one number left. So it's kind of a fold operation or a reduce operation. Right, which is obviously not the right result. But it works for 6. So clear out 1, 2, 3, 4, 5, 6. 1 plus until it's 21. And then 6 plus 1 is 7 times 3 is also 21. So that works. Oh wait, I divided by 2.5 times 15, right. So that algorithm seems to work for any number. So we can apply that up here. Just say distance is equal to this thing, and then distance, wait, what was my formula? Distance plus 1 divided by distance times 2. No, distance divided by 2. And of course here we have floats and integers and all that fun stuff. I'm just gonna make fuel here a float, and we're gonna say, I guess we can say inf, just infinitely high. Inf? Yeah. So yeah, inf I guess should be the same as float.high. I haven't actually ever tested that. Inf, yeah. Oops. So yeah, we set the least amount of fuel to infinite, then we loop through, and now we're doing this as these as floats. I'm gonna echo out the fuel again, and we're still running this in the example input. So if we run this, we have some very wrong results, because this is what we're expecting. So I guess our algorithm doesn't work. Well, that's a shame. Why does it somehow get infinite? Is that because distance is 0? Right. That at least gave us more reasonable numbers, but they're still completely incorrect. Oh wait, I guess they might not be completely incorrect. I mean, they're wrong, but they might not be as wrong as I thought. Right, so so we should all move to 5. Let me do this. So now we're only doing the 5 position. This should be sort of the winning position. And now I can echo out not only the fuel consumption, but I can echo out the distance for each crab. So these numbers should be the same as the numbers from, actually not the numbers from there, but the distances these need to go. So it's just this minus this, and this is 4, and this is 3 and 5, 4, 3, 5, yeah. And these seems correct. But then this is 12. Oh, this is of course meant to be a time spine. This is the same error I did in my calculator. That is more correct. 168. That is actually the correct answer, which makes sense because this is now locked to the correct position. We can do this. Now we can loop through all of them, and we see we have a range of values, and this is the best one. We can also try and use this thing, which should still work. I guess not. Oh, because this is hard-coded to the largest one. The largest one here was 817. So none of those would register. If we run this, we will see a similar graph to before, but the real value is at position 5. 5 and 6 are just so close that they register as the same. Well, yeah, these two values are so close that they show up as the same in our graph, but this is the correct one. It's slightly lower. Right. So we can now do that. And we can run this on our actual input. I'm curious if this can't be this easy, right? Is that actually the answer? I guess it is. I assumed the second part would be like so computationally expensive that we couldn't do it in the naive way. I guess there might have been an even more naive way of doing this. I mean, there obviously is. You could add another loop here, but I don't think that shouldn't be slow enough, even that. So if we do this, this should still give us the correct answer, I believe. This doesn't have to be floats. Okay, so now it's running super slow. Oh, I mean, a couple of seconds slow. Still got the right answer. I guess maybe if you're doing this in a slow language, that might be a problem. Yeah. I mean, the typing stuff in is a lot easier when you don't have to explain what you're doing at the same time. So yeah, for those who couldn't read that comment, Zoom says in the name AoC room, it's funny it's easier for PMunch to derive a formula than to type it in without errors. And yeah, it's easier when you sit down and don't have to say it out loud as you're typing. And I mean, I forgot the formula halfway through typing it out. Yeah, I'm not sure. I want to graph this out again, just for fun, because this was by far the easiest one. Well, maybe day one was easier, but even that was barely. So let's do that. And fuel is now already afloat. Oop. Oh. So make that an int. Ints and floats are a bit annoying to work with in NEM. You sort of end up having to do a lot of conversion back and forth between them, because just typing like normal stuff like abs returns an int, and I can't up convert an int into a float in all cases, which is a bit annoying. Yeah, so here we have a similar graph to what we had before. It goes down, 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 down to our minima down here somewhere. And then we're coming back up the other side to the top. So we could actually, since these don't have, like this is the global minima, it's not just a local minima, and then it dips down again at the end. We could have actually stopped when it started going up again. We could have just cut it there to speed this up, but it doesn't look like it needs any speed ups. I'm not sure if we could have a, I guess we could. Could we have a local and global minima in this situation? I guess maybe not, since every position is linked to every other position. Yeah, I think they would be. I don't think we could have a local and a global minima. So we could actually do if fuel is bigger than least fuel break, and that should still give us the correct answer. Yep. And that would be way faster. I'm gonna comment that out. So yeah, that's part 2. Easy enough. So again, if you want to see my solutions, you can find my GitHub repository here. If you want to watch more of the streams, you can either subscribe to this Twitch channel or to my YouTube channel. All right, yeah. Someone has written the correct formula to me in the YouTube comments. Thanks for that. I should probably have read my YouTube comments earlier so that you didn't have to sit there pulling your hair out about me bumbling around, not figuring out a pretty easy formula. But yeah, so you can find all my code here. You can find my streams recorded on Twitch and YouTube. If you subscribe, I think they should notify you when I start streaming. Of course, the streams aren't super long, so you might not, like, even if you get a notification if you're doing something, you might not be able to see my stream in time. I actually, since this one was such an easy one, I kind of want to see this guy, Mikael Marsalek, tends to have some cool solutions. Just want to see what people are up to. Right, so he sorts them. Interesting. I'd believe that was slower than... maybe not. So he sorts the integers. Then he grabs the median and the mean. And then he has a price, like a cost function, which is the same function that I was using, but with div, so truncating the floating part off. And of course he rewrote it so he calculates this number, and then this division will always lead to a whole number, so it's safe to use div instead of the normal floating point division. So this does integer division instead. This should be way faster. This is actually all integer math. Then he maps. Yeah, he maps all his number over it minus the median. So distance to the middle most position. I guess that... yeah, that does make sense. It's like when you sort them and the number in the middle will be the one that's closest to everyone. That's pretty cool. And for part 2, he actually runs 2 map functions. One that goes to mean and one that goes to mean minus 1. And runs this through the price function. And he maps. So this is actually probably... I would assume this was quite a bit slower than ours. Than my solution here. Simply because... maybe it's a situation of getting nice tight loops. But he first first he sorts his numbers, which is in itself pretty expensive. And then instead of looping through them, well, I guess I loop through all the positions, which is a quite a long iteration. But I guess, I mean, we could end early. But he loops over all the crabs. He loops over all the crabs in one, or he loops over them twice and sorts them. But I loop over them once for every position. Yeah, so mine is probably way slower. Yeah. I don't know the math behind this. The mean, so that is the average, like summing them all together and averaging them up. I'm not sure why I didn't do sdiv2 there. Okay, so yeah, if you like a bit of a more mathy solution, of course his fast solutions are also pretty neat. If you scroll down to solution 7, he has a scan number, so he does his own like scanning of the input, which is a bit faster. Adds those into a sequence, that's fine. He doesn't sort the numbers this time. Still calculates the mean and the median. Oh, he has those as, right, he has created functions for median. Okay. And then he runs the mapit stuff. Okay. Interesting. And that actually takes 0.028 milliseconds, according to his test. On an i5. Wonder what this actually takes. If we enable this early breakout and compile with danger mode. I'm not doing any of the other ones. Now we're also doing floating point math. 0.2, so that is slightly faster than, oh no, this is milliseconds. I think this is seconds. So that would be like 20 milliseconds? No, 2 milliseconds. Yeah, so we have a 2 here. A couple of orders of magnitude slower. Interesting. I wonder how much that is down to doing floating point math. If we rewrite this to his formula, do this. I'm gonna revert this before I put it on GitHub, because this is cheating. That should be an integer, and of course we didn't call it x, we call it pos for position. Compile it with danger mode. About the same speed, it seems. Oh, and the answer was actually 0 when we ran it this time. So the logic is messed up somewhere. I can't see an obvious position where, actually. Doesn't really matter. So yeah, that is basically what I had for day 7. I haven't seen, like, the day 6 was also pretty easy. Apart from the optimizations we had to do in day 2. I've looked at a couple of looked at a couple of solutions for part 2, and they're all pretty much the same as mine, the ones I've seen. So I don't really have any cool solutions to show off either. So that's pretty much just it for me. Hope you enjoyed the stream. Hope you're still having a nice Advent, and I hope to see you back for day 8. So have a good one, and hopefully I'll talk to you some other time.